Right now, as you are watching this, an object from another star system is leaving ours forever. It is moving at roughly 60 kilometers per second. It is already past the orbit of Jupiter, and it is never coming back. Its name is 3I Atlas, and in the final months before it disappeared into the dark, it handed scientists a series of measurements that do not match anything ever recorded in our solar system. A study published in the journal Nature just weeks ago found that this comet carries about 11 times more methane relative to water than any object we have ever measured around our own sun. A separate team at the University of Michigan found that its water is not like our water. And a Harvard astrophysicist went on national television and asked, out loud, whether there could be microbes frozen inside it. Today we break down exactly what was found, why the chemistry of this visitor has stunned the people studying it, and what it means that the strangest object we have ever sampled is now slipping out of reach forever. Before we get into it, drop a comment right now. Do you remember the first time you heard about 3I Atlas? Some of you have been following this object since the very first week of July 2025, and some of you are hearing about it for the first time today. Tell me which one you are, and tell me honestly, did you ever think, even for a moment, that it might be more than a comet? I read those comments, and the range of answers is always fascinating. If you want to be here every time something like this passes through our sky, subscribe to the channel. It is completely free, and it means you will not miss the next visitor, because there will be a next one. A thumbs up helps enormously too. Let us go for 7,000 likes on this video, so it reaches the people who followed this story from the beginning. Thank you. Now let us get into it. On the 1st of July, 2025, a survey telescope in Rio Hurtado, Chile, part of the NASA-funded Atlas network, flagged a faint moving point of light and reported it to the Minor Planet Center. Within days, the orbit calculations came back, and astronomers realized what they were looking at. The object was moving far too fast to belong to the Sun. Its path was not a closed loop. It was a hyperbola, a one-way trajectory, the unmistakable signature of something that fell in from interstellar space and would climb back out again. At discovery, it was already inside the orbit of Jupiter, about 670 million kilometers from the Sun, and it was traveling at roughly 220,000 kilometers per hour. It had come from the general direction of the constellation Sagittarius, which happens to be the direction of the center of our galaxy. It became only the third interstellar object ever confirmed. The first was Oumuamua in 2017, the strange elongated object that tumbled through and sparked years of debate. The second was Borisov in 2019, a fairly ordinary-looking comet, and now this one, 3I Atlas, the 3 for third, the I for interstellar. Here is a detail most people never heard. The comet was almost not called Atlas at all. After the discovery, researchers went digging through archives and found that the brand new Vera Rubin Observatory in Chile had photographed the object 10 days earlier, on the 21st of June, during its testing phase, and then imaged it again and again through early July without anyone noticing. NASA's TESS Space Telescope had it on camera as far back as May. The object was sitting in humanity's data, unrecognized, for weeks. It was very nearly named 3I Rubin. That is how discovery works sometimes. The universe does not announce things. It waits for someone to look carefully. From the moment it was confirmed, a clock started ticking. Unlike every planet, every asteroid, every comet native to our solar system, this object would not come around again. It would swing past the Sun exactly once and leave. Whatever we wanted to learn from it, we had one single pass to learn it. So the world's astronomers did something remarkable. They turned nearly everything we have toward it. On the 29th of October, 2025, 3I Atlas reached perihelion, its closest point to the Sun, at a distance of about 200 million kilometers, just inside the orbit of Mars. At that moment, it hit its top speed, roughly 68 kilometers per second. Think about that number for a second. 68 kilometers. Every second. That is crossing the entire length of Manhattan in under half a second. The fastest spacecraft humanity has ever launched on an escape path move at less than half that speed. This thing was coasting. And here is where a lot of people expected the story to end. Comets that pass close to the sun often break apart. The heat gets into the cracks, the ice turns to gas, the whole fragile structure fails. Borisov partially fragmented. Plenty of native comets have simply dissolved. 3I Atlas did not. It came around the sun intact, and when the Hubble Space Telescope got a clean look at it afterward, astronomers were able to separate the glow of the coma from the solid body inside it. The nucleus came out at an estimated 2.6 kilometers across, give or take about 400 meters. That made it far larger and far more massive than Borisov, a mountain of alien ice built around another star that had just taken a pass by ours and shrugged it off. In December, it made its closest approach to Earth, passing about 270 million kilometers away, no threat to us at any point, and for a while amateur astronomers could actually catch it with backyard telescopes. Then, on the 16th of March, 2026, it made its final planetary encounter, passing roughly 53.6 million kilometers from Jupiter. And since then, it has been doing the only thing left on its schedule: leaving, fading. As of this week, it sits in the constellation Gemini, dimming month by month, so far out that even the James Webb Space Telescope is struggling to see it. One researcher on the Webb team put it simply this spring: it is already getting tough to observe. It is out by Jupiter. So why are we talking about it now, when the show is almost over? Because the most important results did not come from watching it. They came from analyzing it, and those results have been landing one after another over the past few weeks, right as the object slips away. This is the part of the story where the chemistry gets genuinely strange. Start with the finding published in Nature on the 22nd of June, 2026. A team led by Martin Cordner at NASA's Goddard Space Flight Center used the James Webb Space Telescope's near-infrared spectrograph to read the gases streaming off the comet. When sunlight passes through a cloud of gas, each molecule absorbs and emits light at very specific wavelengths, like a fingerprint. Webb can read those fingerprints from hundreds of millions of kilometers away. And in the coma of 3I Atlas, Webb found methane, a lot of methane. The ratio of methane to water measured around this object came out roughly 11 times higher than in any object ever measured in our solar system. Let me explain why that number made people sit up. Methane is what chemists call a hypervolatile ice. It does not stay frozen unless conditions are brutally cold, far colder than water ice needs. In our solar system, comets formed in a zone where methane mostly could not survive as ice, so our comets carry only traces of it. For 3I Atlas to still be loaded with methane after billions of years means two things. First, it must have formed somewhere extraordinarily cold, colder than the region where our own comets were born. Second, it must have stayed deeply frozen for essentially its entire existence, drifting through interstellar space like a sealed freezer that was never once unplugged. The methane is not just a chemical detail. It is a preserved record of a birthplace nothing in our solar system ever experienced. 2 days after that paper came out, the story took a turn that most of you probably saw in your feeds. Avi Loeb, the Harvard astrophysicist who has spent years arguing that we should take the artificial hypothesis seriously for interstellar objects, went on NewsNation and pointed at the methane result. His question, in his words, was whether it could be indicative of microbes in this iceberg. Because on Earth, a large share of atmospheric methane is made by living things. It is a fair question to ask. It is also, according to essentially every other scientist who has looked at the data, not what is happening here. The methane release tracks exactly what you would expect from thermal outgassing. As the sun warmed the comet, frozen methane turned to gas and escaped, in the pattern and the timing that ordinary comet physics predicts. Nothing about the signal requires biology. The consensus from NASA and from the teams doing the measurements is clear. This is a natural comet with an unusual recipe, not a sign of life. But the fact that the recipe is unusual enough to even prompt the question tells you how far outside our experience this object sits. And the methane was only the beginning, because at almost the same time, a completely different team was finding something strange in the water itself. Researchers led out of the University of Michigan published results this spring showing that the water in 3I Atlas carries far more heavy water than comets born around our sun. Heavy water is water in which one of the hydrogen atoms is replaced by deuterium, a heavier form of hydrogen with an extra neutron in its nucleus. Every water source has a ratio of heavy water to normal water, and that ratio is like a birth certificate. It gets locked in by the temperature and radiation conditions where the ice first formed, and it barely changes afterward. Scientists have measured this ratio in Earth's oceans, in our comets, in asteroids, in the atmospheres of planets. 3I Atlas does not match any of them. Its water was made under conditions our solar system simply did not have. An earlier study, published in Nature Astronomy on the 23rd of April, pulled these threads together into a picture of where this thing actually came from. The chemistry points to an origin in an extremely cold, quiet corner of the galaxy, possibly in a planetary system whose star had not even finished forming when this object froze together. Several analyses suggest it belongs to the galaxy's thick disk, an older population of stars, which would make the comet potentially older than the Sun itself. That is worth sitting with for a moment. The Sun is about 4.6 billion years old. This object may have been drifting, frozen, and silent since before our star existed, before Earth, before anything you have ever seen or touched. And for a few months it was here, and in case you are wondering how astronomers can be so certain this thing really came from another star, and is not just some far-flung comet from the edge of our own system, the answer is written in its path. Every object bound to the Sun, no matter how distant, follows a closed orbit, an ellipse, and its eccentricity, the number that describes the shape of that orbit, stays below 1. A long-period comet from the Oort cloud might have an eccentricity of 0.999. 3I Atlas came in with an eccentricity of about 6. That is not a slightly open orbit. That is not even close. It is the most extreme hyperbolic trajectory ever recorded, which means the object arrived carrying enormous speed from somewhere outside, speed the Sun's gravity could bend but never capture. It fell in from the dark, and the same math guarantees it climbs back out. There is no scenario, none, in which it stays. Now, an object like that deserves more than telescopes on the ground, and it got more. This is one of my favorite parts of the whole story, because it turned into the largest coordinated observation campaign ever aimed at an interstellar object. More than a dozen NASA missions turned their instruments toward it, along with the European Space Agency's fleet. Spacecraft that were built for completely different jobs got drafted into comet duty. The JUICE spacecraft, on its way to Jupiter's icy moons, watched the comet in the days right after perihelion, when Earth-based telescopes were mostly blinded because the object sat too close to the Sun in our sky. On the 2nd of November, JUICE measured the comet venting about 2,000 kilograms of water vapor every single second. 2,000 kilograms. Every second. The mission team translated that into a picture anyone can hold. The equivalent of 70 Olympic swimming pools boiling off into space every day. And JUICE found the water was pouring mainly off the sun-facing side, exactly where the heating was strongest, which again is precisely how a natural comet behaves. 10 days later they checked again, and it was still going nearly as hard. NASA's Parker Solar Probe, humanity's sun-skimming spacecraft, photographed the comet daily from mid-October into November. Europa Clipper, cruising toward Jupiter, caught it in ultraviolet from about 164 million kilometers away. The Psyche asteroid mission grabbed observations. The Lucy spacecraft spotted it from around 390 million kilometers. Mars orbiters watched it glow as it passed the red planet. The European X-ray Observatory, XMM Newton, saw it flare red in early December as gas from the comet slammed into the solar wind. Hubble kept returning to it. The SPHEREX Infrared Observatory tracked it for a week in December. Even the Rubin Observatory, the telescope that almost got naming rights, kept it in frame. When people ask what humanity can do when it actually points everything at one target, this campaign is now the answer. but I want to be honest with you about the parts of this story that are still argued about, because a channel that only tells you the comfortable parts is not doing its job. Avi Loeb has published a running list of what he calls anomalies about this object, and a few of them are genuinely interesting, even if you do not accept his framing. Careful processing of dozens of Hubble images taken between November and February revealed a system of 3 small jets coming off the nucleus, separated from each other by about 120 degrees, a strangely tidy arrangement. Astrometry teams have also been tracking a small non-gravitational acceleration, a tiny extra push on the comet's path beyond what the sun's gravity accounts for. Loeb points at these and asks whether we are looking at vents of sublimating ice or at something engineered. The mainstream answer is that jets are common on comets, that outgassing is exactly what produces non-gravitational acceleration, and that the measured push matches the measured venting. When a comet fires 2,000 kilograms of vapor per second off one side of itself, it is a rocket whether it wants to be or not. The push is real. The mystery for most scientists is not. And then there was the test that settled the biggest question most directly. In June, scientists at the SETI Institute used the Allen Telescope Array in Northern California to scan 3 I-Atlas across a wide range of radio frequencies, listening for any technological signal, anything artificial, any transmission, any leakage, any structure in the radio noise that nature does not produce. They announced the result on the 3rd of June. Nothing. Silence across the band. Combined with the chemistry, the dust, the outgassing, the tail, the thermal behavior, every single line of evidence says the same thing. This is a natural object, an astonishing one, but natural. So here is the big question this whole story has been circling, and it is not the question the internet kept asking. The question is not whether 3I Atlas was an alien ship. The evidence answered that. The real question is what it means that the first interstellar comet we ever studied properly turned out to be this different from everything we know. Because think about what actually happened here. For all of human history, every piece of comet and asteroid material we have ever examined came from one single construction site, the disk of gas and dust around our own young sun. Every measurement, every model, every textbook chapter about ices and volatiles rests on samples from one place. Then a piece of another construction site drifted through, we ran our instruments over it, and the numbers came back wrong. 11 times the methane, water that matches nothing local, an age that may predate our star. Our first true sample from elsewhere did not confirm that other planetary systems are like ours. It suggested that ours might be just one recipe among many, and maybe not even a common one. There is honest uncertainty in all of this, and the scientists involved say so openly. One object is a sample size of 1. The Nature paper's conclusions about its birthplace are inference, careful and well-argued inference, but inference. The age estimates carry wide error bars. Nobody can tell you which star it came from, and nobody ever will. David Jewett, one of the astronomers who studied it with Hubble, described the whole encounter as glimpsing a rifle bullet for 1,000th of a second. That is what this was, a fraction of a second of galactic time in which something ancient crossed our path, and we managed barely to read a few pages of it before it moved on. What happens now? Webb was scheduled to take one final look this spring, and it may already have taken the last useful data anyone will ever get from this object. After that, 3I Atlas simply goes dark. It will cross the orbits of the outer planets, then the Kuiper Belt, and in a few decades, it will pass beyond the reach of any instrument we own, back into the interstellar dark it came from, carrying its remaining secrets with it for the next several billion years. Nothing we have can chase it. A few researchers, Loeb among them, have pointed out with real frustration that we had a once-in-a-generation chance to intercept it with a spacecraft, and we were not ready. That lesson landed. The European Space Agency's Comet Interceptor mission, designed to wait in space for a target exactly like this, is now more important than ever. And here's the part that should genuinely excite you. The Rubin Observatory, The telescope that photographed 3I Atlas before anyone knew it existed is now fully online, scanning the entire southern sky every few nights. Astronomers expect it to catch interstellar objects not once a decade, but potentially several every year. 3I Atlas was the third visitor we ever noticed. The fourth is already on its way, somewhere out there in the dark between the stars, inbound and unaware that this time we are watching for it. All of the data from this comet, from every mission that touched it, is going into NASA's public archives, free for anyone, so that when number 4 arrives, we will read it faster and better than we read this one. 1 year ago, 3I Atlas was a smudge in a Chilean telescope that nobody had a name for. Today, it is the best-studied object from another star in human history, and it is leaving with a message we are only beginning to translate. The message is not that we are being visited. The message is that the galaxy builds worlds in ways we have not imagined yet, and that pieces of those worlds are passing through our neighborhood all the time, silent, ancient, and free for the taking, if we are ready when they come. We will be tracking the final Webb observations, the next wave of papers from the flyby data, and every candidate object Rubin flags from here on. Subscribe so you are here the moment the fourth interstellar visitor is confirmed, because that announcement can come any night now. Leave your comment below. Did you think it was just a comet, or did some part of you wonder? Be honest, I read them all. 7,000 likes on this one. Let us get there. And keep an eye on the channel this week, because while everyone was watching this object leave, our own sun started doing something scientists specifically warned about, and that story is next. See you in the next one.